Hello everyone and welcome back to Networking Tips Cisco CCNA 200-301 course. So, if this is the first video you're checking out here on the channel, I do want to let you know that I have one video prior to this one going over the general topics and goal of this course. I would recommend checking that out if you're interested in getting an overview of CCNA and what you can expect throughout this entire course here on YouTube. So, if you've already checked that out, today we will be talking about networking devices. So, I wanted to start off by saying that this is the general kind of foundational information that you will need to understand the rest of what we look at deeper in this course as we prepare for the CCNA. So, on screen you're seeing just a very rudimentary sample network, and I do want to say that if none of this makes sense to you, that is completely fine. By the end of this video you should be able to recognize each of these symbols and what is going on, as well as their purpose in the network. So to do that, we want to first start off by saying what is a network, and I think one of the best ways to start by answering this question is looking at the definition. Now, a computer network is defined as a set of computers sharing resources located on or provided by network nodes. So that may not make sense, and if we take a closer look at this, the real important part here is the last few words: located on or provided by network nodes. So the question we have to ask here is, what is a network node? Well, there are tons of network nodes. We're going to be taking a look at some of the most common ones here in this video, starting with a router. Now, the router is the kind of core part of a network that allows anything on the network to connect outside of the local network, which we'll talk about in just a minute. Another node could be a switch. Switches are typically used inside local networks to connect several nodes or computers, servers, anything like that, to the local network. Another type of node could be the firewall, which is generally the first line of defense to the network from a security standpoint. As you may have guessed, a server is also a network node. This could be any sort of device providing a service to other devices through the internet or just locally on the network. And finally, we have an assorted collection of nodes. Now, I added 3 common ones here, such as a desktop, a laptop, or a phone, but I do want to say that this is not completely inclusive. You can basically think of a network node as anything connected to the network, meaning it could be your desktop computer running Windows, it could be a desktop running Mac OS, same thing with a laptop, could be Windows, Linux, Mac OS, a phone could be an IP-based hard phone, or it could be a cell phone, an Android, an iPhone, and it could be anything in the IoT, Internet of Things definition, such as smart thermostats, security cameras, and others. So while this is just a common depiction of some of the nodes we'll see on a network, know that this is not fully inclusive. So jumping forward here, we want to take a look at building a network. So how do you start to piece together these different nodes? Well, as you can see here, I have just 2 computers in a room, basically, PC1 and PC2. Now, if we connect these together using a cable, this is actually a network. You may be thinking, that's way too simple, how can this be a network? Well, if we take another look here at the definition, a computer network is a set of computers sharing resources located on or provided by network nodes. So really, here we do have a network because we have the set of 2 computers, and one of these may be sharing resources with the other. And by connecting that cable together, it basically means that they can now have a conversation, request things, send things to each other, and function like a network. So while this is simple, this is truly just the beginning of a network, and we'll be taking a look at a little bit more complex network here in just a few minutes. Before we get to that, I want to take a quick look at clients and servers. Now, these are two essential definitions that you're going to want to know. So here I have just a regular desktop depiction, and we're going to treat this as the client. So the definition of a client is a device that accesses a service made available by a server. Now, to understand this definition, you probably need to know what a server is. So if we take a quick look at the server, you'll notice that the definition is almost the opposite here. A server is a device that provides functions or services for clients. So let's take a quick look at how these definitions work in a real network. So again, here is our simple network, PC1 and PC2, connected by that cable. Now, PC1 makes a request that says, please provide photo.png. PC2 responds and says, here is photo PNG. Now, PC1 has that photo. If we take a look back at those definitions, can we figure out which one is the client and which one is the server? If you've said that PC1 is the client and PC2 is the server, you would be correct, because as you can see here, the service of PNG1 or photo.png is provided to the client PC1, which requests it. So whichever one is really providing the service, the file, the video, whatever it may be, this is how you kind of depict clients and servers. Now I want to take one more look at another network. So this one here is similar to what we just saw, a very simple depiction of what you're doing right now watching this video. So on the left hand side we have your PC or phone on your local network. Now, taking out some of the more complex aspects of the network, your PC connects to that cloud in the middle, which we can show as the internet. And on the other side is the YouTube server hosting this video. So essentially your PC says, hey, can I have networking tips CCNA course video? The YouTube server says, of course, get ready to learn, here is the video. Now, what's interesting about this is when you request out to YouTube, they're not going to just dump the whole video onto your computer. They will be sending this in streams. So there will be several different kind of deliveries of that video over to your PC until you've watched the entire video. So in this case, your PC is the client, and of course, YouTube server with server in the name is the server in this case. So, jumping forward here, let's take another look at these definitions to ensure that you've got them in your memory. A client is a device that accesses a service made available by a server, and the server provides those devices, functions, or services to the client. So, let's keep that in mind as we go forward into building a more complex network. So I want to first start taking a look at switches. Now, if you remember, this is a different node on the network, and switches here, as you can see, have several network interfaces. They connect all of those end hosts, your computer, maybe it's a Wi-Fi router that allows your cell phone to connect to the internet or the network. It allows those to connect into the local network. So they often have 24 or more ports when you're in an enterprise setting, but you can get switches that are 4 to 5 ports for home use. These switches provide connectivity to hosts within the same local area network, also known as a LAN, and the switches don't provide connectivity between local area networks over the internet. We'll talk about how you can do that here in just a minute. So taking a look at a very simple network here, we have a company with 2 different branches. You can see branch 1 has 2 different laptops, and branch 2 has 2 different servers. Now, of course, if this is a large company, they would have more than just 4 devices, but we want to start with something fairly simple. Now you can see in branch 1, instead of plugging these 2 laptops together, we actually plug them into a switch. Now the switch allows for an expansion of the company. So if right now you only have 2 employees at branch 1, but you hire 2 more tomorrow, you're going to need 2 more laptops, and instead of running cables all over the place, connecting each one, making sure they can talk to each other, it's a lot easier to plug them right into the switch. That way they can all talk to each other through that switch. We're going to do the same thing over on branch 2. So as you can see, if this PC on the top talks through the switch to PC2, then they are having that same conversation with a little bit of an extra device in the middle, allowing for that expansion. And we have the same thing over on branch 2. Now, if you remember from the slide before, we actually can't use these switches to talk to each other. The switches cannot go over the network, over the internet, and to branches, the branch 2 network. So how do we go about doing that? Well, that's where routers come into play. Routers are what allow you to connect over the internet. So as you can see here, we will add a router to the edge of each branch with the connection into the switch. Now, this successfully allows for the connection of branch 1 to branch 2 through the router. So as you can see here, this top PC makes a request through the switch, goes out to the router, through the internet, into branch 2's switch, and up to that server. Then that server could just reverse course and send everything back with the requested data. So that is how you start to use the actual internet and talk between each other. The routers know who that request is going to, so if that top PC makes a request for the top server, it's going to route it through the internet, through branch 2's local area network to that server, and server will respond same way, just in reverse. Now, taking a quick look at some of the differences here with the routers, you can see they have fewer network interface ports compared to the switches we saw earlier. These are also used to provide connectivity between LANs. Now, the reason that these have a little bit less ports is because of their more advanced configuration. You configure it to the port, and then that port is connected to the switch, which allows all of those end devices to connect and be routable over the internet. Now that we've got a company here with 2 branches that can successfully talk to each other and have room for expansion through those switches, we need to think about threats. Now, if you remember from the first video, there is a security section to the CCNA. Now, the first start here is going to be firewalls. When you're looking to secure a network, there are possible bad actors out on the internet. Not part of your company, but they want to get into your company. They want to steal your data. They want to lock your data down. They want to sell it, make a profit off of it, whatever it may be. And one of the best ways to prevent this is just stop them from getting into the network overall. So by putting a firewall basically what this will do will filter all of the traffic before it gets to the router, and if there's anything that says, hey, I wasn't expecting this, I'm gonna just throw it out. It's not gonna come through, and it's gonna protect your network. So in this case, this firewall would really only be expecting data connection from branch 2. Again, this is a very simple network. So if this firewall sees data connections or requests coming from not branch 2, it's going to just go ahead and throw them out. It's not even going to get to the router and then into the network on branch 1. So this is an example of a firewall on the outside of a network. This one here is a firewall on the inside of the network. So the router will be able to receive those requests from the bad actor, but it will never make it past those that firewall into the switches or the servers. There are various benefits to having it either inside or outside, which we'll get into later in this course. Similar to routers and switches, you can see here that there are hardware firewalls that you would put up in your network physically using cables and connecting them together, and these firewalls are really there to monitor and control the network traffic based on the configured rules that you put in. The firewalls can be placed inside or outside, as we just discussed, and firewalls could also be referred to as next generation firewalls when they include more modern and advanced filtering techniques such as IDP or IPS, which stands for intrusion detection or intrusion prevention. So keep that in mind when you're looking at different networks, different topics, different readings. If you see next generation firewalls, it could just be a firewall with more advanced features. So jumping forward here, you may be thinking, what are the differences between hardware firewalls and software or host-based firewalls? Because you may be thinking, I'm watching this on a Windows computer, and you may be aware that Windows has a built-in firewall. You know you don't have any additional devices on your local home network, but you still have a firewall. So hardware firewalls, like we just looked at, are physical devices that filter the traffic between networks, whereas host-based or software firewalls are software apps that filter traffic entering and exiting specific hosts, such as that Windows firewall. So your Windows firewall is really just protecting your PC and nothing else on the network, whereas a hardware firewall would be protecting the entire network as a whole. So with that being said, jumping back here just to the definition and network nodes, a computer network is a set of computers sharing resources located on or provided by network nodes. As I said at the beginning of this video, you should hopefully be able to identify all of these icons, what they do in a network, and their overall purpose in making a network function. So with that, I hope you found this video helpful in learning about network devices. Please stay tuned here on the channel for an additional supplemental material for this video, where you'll get some additional practice questions and supplemental materials for the networking devices topic. So with that being said, I hope you enjoyed, and I do want to ask you, please like this video and subscribe to Networking Tips to stay up to date on our CCNA course, and it really does help us and allow us to continue providing these videos for free here for you on YouTube. So thank you so much for watching, and I hope to see you in my next video. Bye.